In this picture, I've drawn a quadrilateral and I've shown you the coordinates of each of the vertices. I've also stretched out the picture so that you can't tell exactly what the original looked like. And the question is this, if I unstretched it, is this a picture of a rectangle, or is it a parallelogram, or is it none of those things? Now here's how you might approach answering that problem. In a rectangle or parallelogram, those opposite sides need to be parallel. And this pair of opposite sides need to be parallel. So you need to show that both of those are parallel. And if it's really a rectangle, you need to show that all four of the vertices have right angles. Now, what I'd like you to do is stop the video for a minute. Perhaps draw this on a piece of graph paper in your journal where the x and y axes are divided equally, and see if you can figure out by looking whether you think this is a rectangle or not. After you've done that, we're going to prove it using algebra. So stop the video now, draw this in your journal, and see what you think about whether this is a rectangle or not. All right, to show you about parallel lines, we're going to look at this graph from GeoGebra. The blue line has equation y equals 1.1x plus 1.1, and we can use these sliders up here in the upper right-hand corner to move that line around. So we're going to change the y-intercept to something larger, maybe 4. There we go. And we're going to change the slope to 2. Now we have the line y equals 2x plus 4. Now I'm going to show you a parallel line. Now the red line is parallel to the blue line, and you notice in the equation that the slope of the red line is exactly the same as the slope of the blue line. If we change the slopes of those two lines, now they're 9/10 and 9/10, you notice that they're still parallel. And if I change it to -1/2 and -1/2, they stay parallel. So you notice that no matter how I change the slope, the lines stay parallel. So we learned that if two lines have the same slope, then they are parallel. And if two lines are parallel, then they have the same slope. So now we're going to go back to our original figure and see if opposite sides are indeed parallel. So we'll find the slope of the top side and the bottom side. And you can see that the slopes are equal, so those two opposite sides are parallel. Now we'll do the same thing for the pair of sides, the left and the right side. And we see that both of those slopes are equal, so those two sides are parallel. We'll go back to GeoGebra for a minute, and we'll look at what perpendicular lines are. Now, the blue line is the line y equals 2x plus 4, and now we're going to show a line that's perpendicular to that. And this purple line is perpendicular to the blue one, and let's take a look at its slope. So the slope of the blue line is 2. The slope of the purple line is -1/2. So that is the opposite reciprocal of the slope of the blue line. Now let's see what happens when we change the slope of the blue line. You'll notice that the slope of the blue line is now 8/10, and the slope of the purple line, which is still perpendicular, is now -1/8. So from this we learn that if two lines are perpendicular, their slopes are opposite reciprocals of each other, and if the slopes are opposite reciprocals of each other, the two lines are perpendicular. Now let's see an animated demo of that. I constructed this purple line so that the slope is always the opposite reciprocal, and you'll notice that as I move them around, no matter where I move the lines, and no matter how I change the y-intercept, on either line, both lines remain perpendicular. So let's go back to our original problem and see whether the other two pieces fall in line. In fact, are these angles all right angles? Now let's take a look at these slopes. We've already calculated them, so we don't have to do that again. The slope of this line was 5/2, and the slope of this line was 5/2. The slope of this line was -2/5, and the slope of this line was -2/5. Now you'll notice that 5/2 and -2/5 are opposite reciprocals. You take 5/2, take the reciprocal, find the opposite of it, and you have the opposite reciprocal. So what that means is that this line here is perpendicular to that line, and it's perpendicular to this line over here because -2/5 and 5/2 are also negative reciprocals. And the same thing holds over here. So that line, these lines are perpendicular, and these lines are perpendicular because the slopes of these two lines are opposite reciprocals. Now let me show you what the diagram looks like without being stretched out. And in fact, not only is it a rectangle, but it happens to be a square. And you can see in this diagram that yes, these angles are all right angles and opposite sides are parallel.